Hello everybody, welcome into another lesson. So today we are going to do the last lesson of the variation unit. And today we're going to talk about joint variation and combined variation. First up we have joint variation. Basically you can think of joint variation just as a fancier direct variation. That's really all joint variation is. The difference between joint variation and direct variation is direct variation you're really only dealing with two variables, x and y. In joint variation you're dealing with three or more variables, x, y, and z. And that k is still your constant of variation. That k is still your constant of variation. So you get z varies jointly as x and y. If you ever see z varies jointly as x and y, that means it's going to be equal to z equals that constant of variation k times x and y. So that's how you would deal with joint variation. And I do have some examples here. Alright. We got d varies jointly as r and t. D equals 45 R equals 15, I believe. Yeah, 15. And then T equals 14. Find D when R equals 21 and T equals 8. Okay. So we got the problem D varies jointly as R and T. D equals 45, R equals 15, T equals 14. Then it asks you find D when R equals 21 and T equals 8. Well, start with your first sentence always. D varies jointly as R and T. So that's going to take the form, since D varies jointly as R and T, you'll have D equal to that constant of variation K times R and T. So you would get the equation D equals KRT. And like you would with direct variation or inverse variation, first thing you need to solve for is that constant of variation, k. Well, that means we got to get k by itself. So, in order to solve for k, we need to divide the right side by RT. If we do divide the right side by RT, we get k by itself. But what you do to one side, you got to do to the other. We have to divide the d by RT, so you'll end up getting k equals d over RT. And that ends up being your equation for the constant of variation, k. Now to find the constant, all you got to do is plug in the values of d, r, and t that are given here. So the constant of variation, let's see, d is 45 over your r, which is 15, times your t, which is 14. Well, instead of doing the multiplication in the denominator, we know 15 goes into 45 3 times, right? You'll end up getting 3 in the numerator, and then you'll end up have the 15 in the denominator will cancel out. If you divide that by 15, you'll just have a 14 left in the denominator. So your constant of variation for this equation is going to be 3/14. You could have done the multiplication and then done the reduction, but why go through all the trouble? If you can factor out anything, by all means, please do so. Okay, so we've obtained piece 1 of the puzzle. The constant of variation equals 3/14. Second piece, form your new equation. That's going to be D equals that constant of variation being 3/14 times R. Why am I putting parentheses? That don't make any sense. Times RT. Alright, so the new equation of joint variation is going to be D equals 3/14 RT. Now, last but not least, we have this final piece of the problem. Find D when R equals 21 and T equals 8. So, what we're going to do here is we're going to, of course, solve for D. You'll have D equals that 3/14 times the R that you're given of 21 times the T that you're given of 8. Now, we know between 14 and 21 there's a common 7 that'll factor out. So if you divide that 14 by 7, you get 2. So what you'll have is 3/2 times, now if you divide 21 by 7, you get 3. Whoops, why am I writing 7? Man, oh man. Alright. Times 3 times 8. So now you have 3/2 times 3 times 8. Well, between the numerator and denominator, the 2 will cancel out if we divide by 2. So what you'll have is 3 times 3 times, now if you divide 8 by 2 in the numerator, you get 4. So what you'll end up having left is 3 times 3 times 4, which is 9 times 4, so 36. So D is equal to 36 when R equals 21 and T equals 8. D equals 36. So that's the first problem. So as you're probably beginning to see, this is pretty much just a direct variation, only with more than 2 variables. That's really all it amounts to. Yeah, variables are going to change in every problem, so I'm going to have to rewrite it every time. So let's go ahead and do the next problem here. Let's see. M varies jointly as V and the square of U. We're given M equals 9, V equals 15, and U equals 6. Find U when M equals 60 and V equals 25. Alright, so we have the problem here, m varies jointly as v and the square of u. Let's start with that sentence. M varies jointly as v and the square of u. So now let's talk about some terminology here. The square of u, some people tend to think that means the square root of u. If it meant the square root, it would literally say square root. The square of u means u squared. So if you just see the square, that means u squared. That's the difference. Alright, so m varies jointly as v and the square of u. So what you're going to do is set up your equation. M equals that constant of variation times v times the square of u, which is u squared. So now you have set up your equation. M equals that constant of variation k times vu squared. Well, first thing we have to do is solve for the constant of variation. What that's going to entail is, in order to get that constant of variation by itself, you got to divide both sides by vu squared. You divide the right side by vu squared, you just get k by itself. That'll be equal to, now you divide the left side by vu squared, k will equal m over vu squared. So that's the equation for your constant of variation, k equals m over vu squared. Now, all that's left is to solve for the constant of variation. We just simply got to plug in the values we're given. So k is going to equal the m value of 9 over the v value of 15 times the u value of 6. But that'll actually be to the second because it's u squared. Which means we have k equals 9 over 15 times 36. Well, the 9 and the 36 help reduce because 9 goes into 36. So if we divide the numerator of 9 by 9, you get 1 over 15. Now 30 times your 36 divided by 9, that's 4. So you have 1 over 15 times 4, which turns out your constant of variation will be 1/60th. So your constant of variation for this particular problem is going to be 1/60th. So now we found that piece of the puzzle. We need to find the equation now for the joint variation. That's going to look like m equals that constant of variation being 1/60th times vu squared. So that is your new equation of joint variation, is m equals 1/60th vu squared. Now, last but not least, we have this last part where you find u when m equals 60 and v equals 25. Well, we'll start here. M equals 60, so we'll put in 60 is equal to 1/60th times the v, which is 25, and then we don't know u. Well, that'll be u squared. We're ultimately trying to find u. Well, the first thing I'm going to suggest, on the right hand side, because you have 60 equals 1/60th times 25 times u squared. I'm going to suggest get rid of your denominator of 60. In order to do that, you got to multiply both sides by 60. If you multiply the right side by 60, you're simply left with 25 u squared is equal to, now you'll have 60 times 60, which would be 3,600. So we have now 25u squared equals 3,600. Well, we want to get the u squared by itself, right? So that means you got to divide both sides by 25. You divide the left side by 25, you'll get u squared. That's going to be equal to the result of 3,600 divided by 25. So let's go ahead and do that. You get 144. So now we have u squared is equal to 144. Well, here's the thing. We're looking for u. We're not looking for u squared, we're looking for u. So, in order to find u, obviously you got to take the square root of u squared. If you do that, you'll get u is equal to plus or minus the square root of 144. Because when you have a quadratic equation with a variable, the right side is plus or minus the square root of that number. You get two results. And we all know the square root of 144 is 12. So ultimately, u is going to equal both plus and minus 12. And that would be your answer. When m equals 60 and v equals 25, u is equal to both positive and minus 12. So it's kind of like what we did yesterday with some quadratic direct variation. Not really any different, just there's more variables, more numbers to plug in. It's really no different. So that's it for the joint variation. Now let's talk about combined variation. We will discuss combined variation. Alright, so let's lay this out. Combined variation. Well, combined variation takes both direct and inverse variation and puts them together in one problem. Here's how it works. You'll have something like z varies directly as x and inversely as y. So yes, you can have both types of variation in the same problem. That's what's called a combined variation. When z varies directly as x and inversely as y. So how do you set this up? Well, we'll start with the z. That's equal to, of course, your constant of variation always comes first, your k. So z equals k so far. Then it says directly as x, so that's going to be k times x, and inversely as y. So that means it'll be that kx divided by y. So what you'll have is z equals kx over y. When z varies directly as x, so z equals kx, and inversely as y, you'll divide the right side by y. And that is how you set up a combined variation. And I do got some problems for that too. Alright, so let's start with the first problem here. Let's see. C varies directly as A and inversely as B. You're given let's see. C equals 15. A equals 18. And B equals 40. So find C when A equals 36 and B equals 25. All right. So we have a wonderful combined variation problem here of C varies directly as A and inversely as B. They give you C equals 15, A equals 18, and B equals 40. Then they want you to find C when A equals 36 and B equals 25. So, like any other variation problem, start with your first sentence. C varies directly as A. Start with that first part. So C equals still K, your constant of variation, times A, and inversely as B. So that means you're going to take that Ka and divide it by B. So you got your initial equation of C equals Ka over B. Well, the ultimate goal is to get that K by itself to solve for the constant of variation, is it not? First thing I would do is multiply both sides by B. If you do that, you get the Ka by itself. That'll be equal to BC. So we have Ka equals BC. Now we just want to get that constant of variation by itself. In order to do that, you're going to have to divide both sides by A. If you do that, you get K equals BC over A. So now we have actually found the equation for the constant of variation. All that we got to do now to solve it is plug in the values we're given of each variable. So K equals the value of B being 40 times the value of C we're given, 15, over A, which is 18. Well, let's see here. Let me see if this becomes anything nice. All right. Well, what I would do is start factoring out common terms. Between 40 and 18, there's a common 2, is there not? So K, if you divide 40 by 2, you get 20 times the 15 over 18 divided by 2, which is 9. Now between 15 and 9, there's a common factor of 3. So you'll get K equals 20 times 15 divided by 3, that's 5, over 9 divided by 3, which is 3. So you have K equals 20 times 5 over 3, which we know is 100 over 3. So the constant of variation is 100 over 3. We found the constant of variation to be 100 over 3. Now we got to set up the new equation, which is going to look like C equals, really you could split up K, make this K times A times B, because K is 100 over 3. So you'll take that times the A over B, which means your new equation really is going to be 100A over 3B. That's really what you would get. Your new equation of combined variation is going to be C equals 100A over 3B, because you can take K, since it's in the numerator, which would be K over 1, it'd be K times A over B. So you take that 100 over 3 times A over B, then you just get 100A over 3B. That's how we come up with a new equation. So we found the constant of variation, we found the equation of variation. Now we're being asked to find C when A equals 36 and B equals 25. So we're going to solve for that. Let's find C equal to 100 times the A being 36 over 3 times your B being 75. No, I'm sorry, B's 25, excuse me. I'm thinking of what the result's going to be in a minute, but... Well, instead of doing all the multiplication, why don't we look for things we can factor out, right? So, for example, 125, they have a common factor of 25. If I divide 100 by 25, let me change that here. We get C is equal to 4 times 36. Now 25 divided by 25 is 1, so this is just over 3. Now we just have C is equal to 4 times 36 over 3. Well, we know 3 is a factor of 36. So what you're going to have next, you'll take C is equal to 4. Now you take 36, divide that by 3, that's just 12. So you have 4 times 12. 3 divided by 3 in the denominator is just 1. So now all you got to solve for is C equals 4 times 12. That means C equals 48. So when A equals 36 and B equals 25, C has a value of 48. And I do have more. Combined variation can be the hardest because it combines both inverse and direct variation in the same problem. But if you're comfortable with inverse and direct variation, then joint and combined variation really aren't that big a deal. It just simply combines them or adds more variables. It's really not that bad. Okay, so what's the next problem here? Let's see. C varies inversely as h squared and directly as n. Let's see, we get C equals 1. H equals 11. And N equals 50. Find H when C equals 3.63 and N equals 6. Alright, so we have the following problem here. We have C varies inversely as h squared and directly as n. So let's start with that. C varies inversely as h squared. So C equals your constant of variation over h squared, since it varies inversely as h squared and directly as n. So that means you're going to take this whole thing, multiply by n. You just end up having n in the numerator. So what you'll get is C equals kn over h squared. That's how you would get your equation of combined variation to start with. Now, of course, we want to find the equation for the constant of variation, because that's the first thing we need to find. I would start with multiplying both sides by h squared first. If you do that, you'll get, on the right side, you'll get kn. That'll equal ch squared. So you'll have kn equals ch squared. Now, what we have to do to solve for k is just divide both sides by n. You'll end up getting k is equal to ch squared over n. That ends up being the equation for your constant of variation, is k equals ch squared over n. Now, like you would any other problem, once you've obtained the equation for your constant of variation, just plug in the assigned values you're given. So k equals, well, we know c is 1, so we'll have 1 times your h squared, which is 11 squared, over n, which was 50. Well, this won't be too bad. That 1 can go away, because anything times 1's itself. 11 squared, that's 121. So what you're left with for your constant of variation is k equals 121 over 50. So your constant of variation is 121 over 50. Now, what you have to do is find your new equation of variation. I'm going to write that up here. So what you can do is take c is equal to k times n over h squared. That'll also work, which means c is going to equal that 121 50ths times n over the h squared. So that means your new equation of combined variation is 121n over 50h squared. So that is your new equation of combined variation, is c equals 121n over 50h squared. Okay, so we have found our constant of variation. We've even found our equation of variation. Now the last thing we have to do, find h when c equals 3.63 and n equals 6. So, ultimate goal first is to solve for the h, right? That means we need to get that term, the whole term that has 50h squared, out of the denominator and out the right-hand side. So in order to do that, we have to multiply both sides by 50h squared. If we do just that, on the left side, if you multiply the left side by 50h squared, you get 50ch squared is equal to 121n, because if you multiply the right side by 50h squared, you just get 121n. Well, we've solved part of it. Ultimately, we want to get the h squared by itself, so you'll have to divide both sides by 50c. If you do that, you divide the left side by 50c, you get h squared by itself. That'll be equal to, let's see, 121n over 50c. So what you'll have now is h squared equals 121n over 50c. Now at this point, since you've got the equation for h squared by itself, go ahead and plug in the value of the variables you're given. We're trying to solve for h, so all we're given so far is h squared. That's going to equal 121 times your value of n, which was 6, over that 50 times your value of c, which was 3.63. Now we'll get h squared. We're going to work through the results of this, and we're going to take the answer to 1 decimal place ultimately. So first I'm going to do 121 times 6, which gives me 726. Then we have 50 times 3.63, which is 181.5. So we take 726 divided by 181.5, we get exactly 4. Okay, we get an exact number. So we get h squared equals 4. Well, that's great, we have h squared, right? But we're being asked to solve for just h. Well, if we want to solve for h, we got to take the square root of both sides. Take the square root of h squared, you simply get h. But when you have a square variable equal to a number, it's plus and minus the square root of the number on the right. So we have h equals plus and minus the square root of 4, which, as we know, h would then equal plus and minus 2. So you would have two answers since h is quadratic. So when c equals 3.63 and n equals 6, h has a value of both plus and minus 2. I know it's a little all over the place, but I know these problems could be a lot of work, but they are necessary to be taught. And as I said, this is the last lesson in the variation unit. We'll move on to a new unit starting in the next lesson, which most likely will be tomorrow unless something drastic happens in my life, but we'll pretty much plan for tomorrow for the next lesson. Alright, let's do one more. Let's see. The square of y varies inversely as x and directly as z. So we're given y equals 3, x equals 12, and z equals 21. Find y when x equals 8 and z equals 28. Alright, so let's start with the problem here. This time it's a little different. The square of y varies inversely as x and directly as z. So y is the one that's being varied, but it's the square of y. So that means it's going to be y squared is equal to that constant of variation. And it varies inversely as x. So far you have k divided by x. And then it varies directly as z, so you'll take the whole right side times z, you'll end up getting kz over x. So you get the equation y squared equals kz over x. Now, the idea is we want to find the equation for the constant of variation to get k by itself. First thing I would do is multiply both sides by x. If you do that, multiply the right side by x, you simply get kz. Then multiply the left side by x, you'll get kz equals xy squared. Then ultimately you want to get the k by itself, so you got to divide both sides by z. So let's divide the left side by z, you will get k by itself. That'll be equal to the right side divided by z, so you'll get k equals xy squared divided by z. So that's the equation for the constant of variation. Now all we got to do to find that constant of variation is plug in the assigned values. So we'll solve for k. That's going to equal, the x value given to us was 12, times the y value. Y was 3. That's actually going to be 3 to the second, since it's y to the second, all over the z value, which was 21. Alright, now what we have here is we have k equals 12, and 3 squared is 9. You'll get 12 times 9 over 21. Well, pick your poison. 12 and 9 and 21, all three have a common factor of 3 in common, do they not? So I'll go with 12. We'll get k equals 12 divided by 3, which is 4, times 9, all over 21 divided by 3, which is 7. That means your value for k, your constant of variation, 4 times 9 is 36 over 7. So the constant of variation is equal to 36 over 7. So that's one piece of the puzzle. Now we need to find the equation of combined variation. You're going to stick with your y squared. That's going to equal, really you can take that as k. Let's move this up some so it's out of the way so I can solve. We'll get y squared, you could say, is equal to k times z over x, which means y squared equals that constant of variation, 36 over 7 times z over x, which means that your new equation should be y squared equals 36z over 7x. So that is your new equation of combined variation, is y squared equals 36z over 7x. Now, we found our equation of variation as well. The last thing we're asked to find is find y when x equals 8 and z equals 28. So, let's go ahead, form our equation. We'll get y squared is equal to 36. Now times your z value of 28, so you'll have 36 times 28 over 7 times your x value of 8. Well, I can tell you right now what you can do is to start with, 7 is a factor of 28, is it not? It certainly is. So what we'll have here now is y squared equals still 36, but if we divide 28 by 7, you just get 4, so you'll have 36 times 4, Now 7 divided by 7 is 1, so that goes away. You'll just have 36 times 4 all over 8. Well, we also know that 4 is a factor of 8, is it not? So we'll have y squared still equals 36 in the numerator, but 4 divided by 4 is 1, so that goes away. Now if you divide the denominator of 8 by 4, you get 2. So you now have y squared equals 36 divided by 2, which means y squared equals 18. Well, we finally got a value for y squared, but they're asking for just y. In order to find just y, you need to take the square root of both sides. So take the square root of y squared, you'll get y. But remember, when you have a quadratic, you take both plus and minus the square root of the right-hand side. So y equals both plus and minus the square root of 18, which we know is not a perfect square. So we're going to round our result to 1 decimal place. That means y is going to equal plus and minus. Let's take the square root of 18. To 1 decimal place is about 4.2. So that means that when x equals 8 and z equals 28, y equals plus and minus 4.2. So that's been it for the variation unit. If you understand direct and inverse variation, joint variation won't be hard and combined variation won't be that bad. So that's it for that. Next lesson we start a brand new unit on systems of equations. We're going to be solving those. So I hope everybody has a good night. Take care.